This is our example for the truth table of compound proposition, which is the part 2 of the discussion, in which there are also 3 given problems to be solved here using the truth table. Okay, so number 1, we have P and not P. Okay, so there is only one variable. So P can be answered by true or false only. And its negation P would be false and true. So that P and not P would be true and false is false. And false and true is also false. Take note that the conjunction of two propositions can only be true when the truth values of these two propositions are true. Okay, so we have here true. Okay, and the second one is number 2. P implies Q if and only if not Q implies not P. Okay, so this time we have two variables, which are P and Q. Okay, so again, there are two expressions here. We have P implies Q and not Q implies not P, and connected by conditionality, or if and only if connectives. So we have not Q and not P. P implies Q and not Q implies not P, and therefore we have P implies Q if and only if not Q implies not P. Okay, so since there are 4 variables, then we must have 4 rows. So we have 2 true and 2 false under P. For Q, we have true, false, true, false. So this is now the arrangement of our true or false given 2 variables. The negation of proposition P would be false here. The negation of true is false. The negation of false is true. The negation of true is false, and the negation of false is true. And the negation of P would be false here, false, true, and true. So that P implies Q means that the conjunction or the conditional statement, okay, P implies Q is true, is false when the first proposition is true and the second proposition is false. So we take P implies Q. So we have here our, okay, false, and the others are already true. Okay, so take note that in the implication or conditional statement, P implies Q is false only when the first proposition is true and the second proposition is false. Same is true with our not Q implies not P. So we have this one also. Okay. So in our not Q implies not P, we have false here. So true implies false is false. False implies false is true. False implies true is true, and true implies true is true. Therefore, the final answer would be biconditional. Again, for biconditional, take the values of the two propositions which are both the same. So true, both true and both false, so that the value is true. So in here we have true, okay? True if and only if true is true. False if and only if false is false. No, true, I should say. And then true if and only if true. And true if and only if true. Okay, so that the truth value of this compound proposition could be true, 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 true. Okay, and for number 3, we have P or not R and Q or not P. Okay, so again, since we have 3 variables P, Q, R, we have our P, we have our Q, and we have our R. Okay, then we must have 8 rows, 4 true and 4 false. Okay, so we have here true, 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 false, 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 and false. For proposition Q, we have 2 true and 2 false. 2 true and 2 false. For the third variable, we have 1 true, 1 F, or false, 1 true, 1 false, true, false, true, false. So that in the first expression, we have P here, we have P or not R. So we need our R here, or the negation of R, so we can formulate our P or not R. The negation of R is false, true, false, true, false, true, false, and true. So now we have our first expression, P or not R. So we combine the first and the second column through the disjunction connective. Okay. So again, the disjunction of two propositions could only be false when both of the propositions are false. So we have, okay, P or not R. So T or F is true. True or true is true. True or false is true. True or true is true. Okay. False and false is false. False or true is true. False or false is false. And false or true is true. Okay. So we have our not P here. Okay. Then the negation of not P would be false, 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 true, 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 and true. Now we are ready to find the truth value of Q or not P. Okay, Q or not P. Next is we combine, okay, Q and not P. Q and not P. Okay, so disjunction, we have false only when two propositions are both false. So true or F is true. True or F is still true. false or false is false, and false or false is also false. True and or true is true. True is true. False or true is true. And false or true is true. Okay. And finally, we have the combination for P or not R and Q or not P. Okay. So in the conjunction, we only have true if both propositions are true. So here we have P or not R and Q or not P. Okay. So we have the connective as conjunction or and. So true is true. True is true. True false is false. Okay. True false is false. False true is false. True is true. False true is false. And true is true. Okay, so true is true. False and true is false. True and true is true. False and true is false. True and false is false. True and false is false. True. Okay. So this is the truth value of P or not R and Q or not P. Okay. Thank you.